Hey guys, welcome back to the Pepcoding. So in this video, we are going to discuss our next question, that is find rotation count. In this question, we have an sorted rotated array of size n, and it is rotated by k times, and we need to find the value of that k. Okay, so this is an given array and it is rotated by k's time. So if it is not rotated, then it looks like 0, 1, 2, 3, 4, 5, 6, and sorry, not 3, 4, 5, 6, 7, and 8. The last 5 elements are shifted from right to left. Okay, so it looks like this. Then, so this is the same question as the previous. In that previous question, the previous question was also find the minimum element in rotated sorted array. Okay, and this is the question that we need to find how much times this array is rotated by. Okay, so in that question, we are dividing this array into two parts. So the first one, okay, the first one, and this is second one. This is the second part. Part 2's first element is the minimum element in this array. Okay, and part 1's last element is the maximum element in this array. If we have the count, we have the index, the minimum elements index, then we have the array answer of that k. Okay, because this array is rotated by k times. K times means 5 times. Okay, 1, 2, 3, 4, and 5 elements, and it is less than of this minimum element. Okay, so this is the approach of this question. I recommend you to pause the video here and code by yourself. So let's start with the solution. So for finding the minimum elements index and for finding the k times, which times k times this array was rotated. So for finding this, we are starting with the binary search. Okay, and low is starting with 0 and high is starting with array dot size -1. Okay, so the while loop will be run at low is less than equals to high. Now we need mid element also. Mid is equal to low plus high divided by 2. Okay, now the first condition, if we our mid is this, if our mid point is this, and first we need to check that it is in sorted order or it is not. Then if our array of mid is greater than array of mid plus 1, and this condition is true here because it is greater than this and it is not possible in rotated order, ascending order. Okay, so this condition will be true, then we need to return the next element's index. Why? Because the next element is the minimum element of this element, so we are returning mid plus 1 here. Okay, so let's write the condition here, that is array of mid, if it is greater than array of mid plus 1. If it is greater than mid plus 1, then we are returning mid plus 1. Now else if our mid is this, if our mid point is this, then we need to check that this at its left. Why? Because all the elements on it is sorted from this point to this point. Okay, now we need to check that this element, if it is less than, if this mid is less than array of mid minus 1, if this element is less than array of I minus 1, mid minus 1, then we are at the minimum elements point now, and we need to return the original position, that is mid position. So if this minimum element, if this mid element is less than array of mid minus 1, then we are returning midpoint here. So if array of mid less than array of mid minus 1, just return mid because we are at right point. Now if array of low is less than equals to area of mid. If this condition will be true, if our low is here and high is here and our midpoint is this, now in this region all array are sorted and we can't get our minimum element, so we are update our low, that is mid plus 1. Okay, and same condition from this, if it is if it is not there, then we are updating our high as mid minus 1. So updating low is equal to mid plus 1. Else that is uh, if array of mid is less than equals to array of high, if it is true, then we are we are updating our high as a mid minus 1. Okay, so this is some conditions. Now we need to also check for if the given array is not sorted order. If it is 0 1 2 3 4 and 5, if it is not in sorted order, then we need to return the minimum elements index. So what is the index of this? This is 0. So if we checking that if array of low is less than array of high, if it is less than array of high, then we are easy to return that zeroth index. Why? If this condition is let's apply this condition over this array. If array of low is less than array of high, if it is less than this, then we need return this. But it is not less than 4, is not less than 2, so we are not so let's write that array of low is less than array of high, so return 0 from here. Okay, so this is the code. Let's try to run this code. So let's try to submit it. So submitted. So let's try to try run this code first. This is our code. Let's take this onto our open board. So this is our code. Okay, now this is the low point and this is the high point. Okay, now we are not getting into this. Why? Because 4 is not less than 2. Okay, now we are in while condition. We are finding the midpoint is here. Why array of mid is greater than mid plus 1? It is greater than? No, it is not greater than. Array of mid is less than mid minus 1? It is not the less than. Then if array of low is less than equals to array of mid, yes it is, then we are updating our low as mid plus 1. So low here as of now, low is here. Now again we are finding our mid, so mid element is this. Okay, now checking array of mid is greater than equals to is greater than array of mid plus 1. Yeah, it is not. This 0 is not greater than 1. So next condition, 0 is less than 8, array of mid is less than array of mid minus 1. Yes, it is true. Then we are returning our mid. So our answer will be 5 here. Okay, so I hope you understand the question and the solution of this question. So thank you for watching.